Hello everyone. I hope everyone is well and your studies are also going well. So today I am here with another topic known as electric dipole. But before I start this topic, let me remind you all the topics that we have read till now. So we have read about static electricity, then we have read about charge, then we have read about Coulomb's law, which describes the force between two charges. It may be either attractive or repulsive. Then we have discussed about electric field. Every charge creates a space around it where it executes a force, exerts a force on any other charge present near it. Then we have studied about electric lines of force. Okay, we have also studied about continuous charge distribution, different type of charge distributions and also discrete charge systems. Then we have studied about electric lines of force, and here we are with another topic related to electrostatics and also a very important topic. It is a very important topic. Okay, and it is known as electric dipole. So, as the name suggests, electric dipole, electric means something related to charge, and dipole, two ends of a pole. So, in physics, what is the definition of electric dipole? So, it means that it is a pair of equal and opposite point charges placed at a short distance apart. So, here you can see I have already drawn two charges. So, equal and opposite, these two are equal charges of equal magnitude and these are of opposite sign, one is minus, one is plus, and these two are separated by a small distance, 2L. That's why it is said dipole, two ends of a pole. So here you see these two are apart by a short small distance, 2L. Now the strength of an electric dipole is measured by a quantity known as electric dipole moment. It measures the strength of an electric dipole and it is denoted by P, small p. Okay, so electric dipole moment is written as P equals to magnitude of any charge. So these two are of the same magnitude, so you can take any magnitude into what you can take? You can take the distance between the two charges. That means we take the distance, here the distance is 2L, so we take it as Q into 2L. Now it is not necessary that you have to take always 2L. You can take the distance as A also. Then if the distance is A, suppose, you can take it like this also. But we are taking 2L so that the deductions that we do should be easier. So the deductions that we do becomes easier. For that reason we have taken it 2L. Means for mathematics simplicity we have taken it as 2L. You can also take it as L also. So now electric dipole moment is actually a vector quantity. So vectorially we can represent P as P vector to Q 2Q L vector. Okay, so we can keep the 2 here also. So in this way we can represent this vector. Now what is the unit of SI unit? SI unit of P. What is the SI unit? You can easily understand, it is the product of charge into distance. So Coulomb and SI unit of distance is meter. So Coulomb meter is the SI unit of electric dipole moment. Now what is the direction? Since it is a vector, in which direction is it represented? So always remember it is directed from the negative charge towards the positive charge. That means if it is a P vector, it is always in this direction. from the negative to the positive charge, and it is always directed along the line joining the two charges. Okay, like electric field, then force also points along the line joining the two charges. So if this is the line, it will point along that line only, and always remember it points from the negative to the positive charge. Now we will see how to find out the electric field due to an electric dipole at two positions, one at the axial position and another at the equatorial position of an electric dipole. Let us see now how to find out the electric field at an axial point of a dipole. But before that, let me mention one thing. Examples of electric dipole are H2O, HCl, etc. These are examples of electric dipole. Why? Because if you see the example of electric dipole, suppose you take HCl. So H is a positive center and Cl is a negative center, and these two are separated. So H is always has plus 1 charge, suppose, and Cl has minus 1 charge. So, and these two are separated by a distance, so that means it represents an electric dipole. Okay, so H2 also similarly, H has the positive center and O is the negative center, and these two are separated by a distance, so this also represents an electric dipole. So now let us begin with electric field at an axial point of the dipole. So here we have taken two charges, one is minus q, another is plus q, and these two are at a distance 2l, and let us mark the midpoint of this. So let it be O, suppose O. Now we have taken a point P which is at a distance r from the midpoint of a dipole. So you always have to take the distance from the midpoint of a dipole. And this point P we have taken on the axial line of the dipole. Means axial line is the line passing through the center of the two charges. Okay, so this is a line. This is a line through the axis of the two charges, passing through the center of the two charges, and if we extend it, suppose if we extend it in this direction, here we will take a point P, and we have to find out the electric field at the point P, which is at a distance r from the center of the two poles. Now, what will be the electric field due to minus q charge at P? At P, what will be the electric field at P? Okay, what will be the electric field due to minus q charge? So it will be 1 by 4 pi epsilon naught. We know the normal formula, q by r squared. So let us take q by r squared, it is distance square. Now how far is the distance of minus q from P? So if this distance is r, and if you break it into two parts, 12, L into L it will be, so r plus L. Okay, and it is directed along so let us see in which direction it will be directed. Now this is a minus q charge, and here if you imagine there is a plus 1 charge, that is a charge of unit magnitude, positive unit magnitude, then that charge will obviously be attracted towards this charge. That means the electric field here will be in this direction. Okay, so this positive point charge will be attracted towards the minus q charge. That means direction is along PO. We can say direction along PO, we can say. Now E plus Q. We are writing it in scalar form. We are not putting the vector sign, so we can write in this manner only. So E plus Q is in which direction? So plus Q is at which distance from point P? It is, now this is R, if this is L, so this much distance will be what? R minus L. Okay, so this is R minus L and it is directed along OP. Okay, it is directed along OP. Now, okay, now why it is directed along OP? Since you see, this is a plus charge, and if you imagine here is a plus 1 unit charge. So, obviously since this is plus, it is also plus, it will feel a force of repulsion. So, therefore, its electric field will be along this direction. Okay, so therefore, it is along this direction and it is along this direction. So that means these two fields are in opposite directions. So what will be the resultant field? So the resultant electric field E will be. Now resultant electric field, how we can find it out? Now which one is of larger magnitude? If you see, this one is of larger magnitude since its denominator is small, so it will be of larger magnitude. So if you write E plus Q, so plus of minus EQ, since these are in opposite directions. Okay, but the resultant, if we write it as plus, we are writing the general formula, it as plus EQ plus. Now since it is in opposite direction to this, we are taking it as minus, so we can write E plus Q minus of EQ. Sorry, here it will be E minus Q. So here we go. So now let us put the values. Now let us see this 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, and Q is common between these two. So we can take it outside, Q by 4 pi epsilon naught. Now what remains? So 1 by R minus L minus of 1 by R plus L. This is our denominator. Okay, so we forgot to put the square. Let us put the square. So be careful with this. I always have a trouble with this. So you all please don't forget putting the square. It is very much important, otherwise your total expression will go wrong. Now let us take the LCM. Square into R plus L square, it is R plus L whole square minus R minus L whole square. Okay, so let us rub this portion. So from there we can this is C, A plus B whole square minus A minus B whole square. So this we can write it as Q by 4 pi epsilon naught equals to, so A plus will be 4 AB. So that means 4 RL. And this is A plus B whole square, A minus B whole square. This we can write it as R square minus L square whole square. Understood? If you don't understand how did we get this formula, you can break it into parts. R square plus L square plus 2RL minus of again R square plus L square minus of 2RL. Then you see how many terms get cancelled, and finally you will get this 4RL. So this is the formula. Now let us rearrange it little bit. Let us have 2. So let us 2 QL. 2QL. Let the R be outside. R square minus. Just erase this portion. So what did we do? We kept the r outside the bracket. We took 2ql inside. And what remains? 1 by 4 pi epsilon naught to p r square minus l square whole square. So we are getting where? How did this? Why did we arrange this in this manner? Since we have learned that dipole moment equals to 2ql. So to put p in here, we have arranged this in this form. So here we are left with this formula. Now for r much greater than 2l. Now suppose this r, this distance, that is this point P, is at a very higher distance from O. Okay, P is very far from the dipole. Then what will happen? E will be 1 by 4 pi epsilon naught. We will neglect L. Okay, 2L and L, if we neglect 2L, so L will be automatically neglected. So what will happen? So 2PR, and this R, if there is no L, so R square, and outside there is another square. So it will be 1 by 4 pi epsilon naught 2p by r cube. R to the power 4 and r gets cancelled and we are left with 2p by r cube. So this is the formula for electric field at an axial point of a dipole. Now you can see it is a scalar form. If you want to write it vectorially, how we will write? Vectorially, how to write this? E vector equals to 1 by 4 pi epsilon naught. So we have taken the direction minus from E plus Q to E minus Q. That means the electric field is directed in this direction towards the right. So if you write it as 2p vector by r cube. That means if you take the dipole moment vector, so dipole moment will be directed from the negative to the positive charge. That means if we erase this, dipole moment will also be directed along this direction from the negative to the positive, and electric field, this is also directed from the negative towards the positive. That is, this is also along OP if you take, that means it is directed from O towards P, and dipole moment vector is also from negative towards the positive charge, that is towards this direction only, towards right direction only. That means, or you can say E is towards the dipole moment vector. E is along the dipole. So here you can put one subscript E axial. So E axial vector equals to 1 by 4 pi epsilon 2p by r cube. So this was electric field at an axial point of the dipole. Now we will see electric field at an equatorial point of a dipole. So now let us see how to find out the electric field at an equatorial point of a dipole. So what is an equatorial point? This is the two charges. These are the two charges, and these are separated by a small distance 12. And if we draw a line which is a perpendicular bisector of this line, that is, the line is like this. And if we take any point on this line as P, suppose we take any point on this line as P, and we join this P with the two charges. Okay, so here it is P joined with this minus Q, and here it is again joined with the center of the positive charge. So this is your distance between the two charges, and the distance of point P from point O is R. So now let us see how to find out the electric field at point P. So electric field due to minus Q charge will be what? 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught charge by distance. Now distance, which distance you want? From P to the minus q charge, the distance. Now since it represents a right angled triangle, since this is perpendicular bisector, that means it is 90 degree to this line, that means it represents a Pythagoras triangle, or that means Pythagoras theorem has to be used in this triangle. It's a right angle triangle, so we can easily write it as root over r square plus l square. That is, this distance is root over r square plus l square. Okay, and it is directed along which direction? Directed, if this is point A and if this is point B, let us name it as point A, it is point B. So the minus q charge, suppose imagine, again you imagine there is a plus 1 charge kept here. So that charge will be attracted or repelled by this minus q charge. So definitely, since it is minus and if we imagine a plus 1 charge here, it will be attracted towards this minus charge. That's why it will be directed along PA. Okay. So now let us see what will be the electric field due to the plus charge. So it will be 1 by 4 pi epsilon naught, again charge by distance. So again this distance will also be the same as this one, plus L square, and it will be along, see we are writing the scalar form, we are not writing the vector form. So it will be along which direction? Now see, if you imagine again a plus 1 charge here, so now it will be directed along which direction? The electric field. Now this is plus charge, if there is also plus charge, it will feel a force of repulsion. That means, sorry, we have not drawn the electric field here. So electric field E minus Q is this direction, and electric field here will be, so that means if plus 1 charge is here, it will be repelled along this direction. Okay, it will be repelled along this direction. So therefore we write here as plus Q. Okay, so this is the direction of the electric field along, this is B, and it will be directed along BP. Now you see, this minus Q charge is equal to plus Q charge. Magnitude wise these are same. Okay. Now we can understand that here there are two electric fields. One is plus Q, another is minus Q. Now we at a single point we can have only one direction of electric field. Now that electric field is given by using parallelogram law of vector addition, you think. So the third vector or the resultant vector will be along this direction. Now if this is theta, this is also theta, corresponding angles. If these two lines, you imagine that these are parallel lines, then this will also be theta. That is corresponding angles. This one is theta, again this one is theta. Okay, so now if that angle is theta, then what will be the electric field along this line? So here the electric field due to this component will be E plus Q cos theta, and due to this component will be E minus Q cos theta, because if the perpendicular will be E plus Q sin theta, then the base will be E plus Q cos theta. So again along this direction will be, due to this component will be E minus Q cos theta. So to find out the resultant E at electric field at P will be what? E equals to E plus Q cos theta plus E minus Q cos theta. Okay, this is the resultant electric field. So since these two are of the same magnitude, we take any one. So 2 EQ cos theta. We take any one since these are same. So 2e plus q, 2e plus q. What is the magnitude? 4 pi epsilon naught q by root over r square plus L square, and cos theta. What is the value of cos theta? If you see cos theta from here, base by hypotenuse, base will be L. Base will be L because we want this much L, so half of 12 will be L. Base by hypotenuse. So hypotenuse will be this one, r square plus L square. Got it? Now let us erase this portion. Our space is less. So if you see here, it will be 2 into 1 by 4 pi epsilon naught QL. Here there are root over and root over. So 2 root over will give us this value. Okay. Okay, sorry, I made one mistake. Again I forgot to put the square, so be careful. We had this plus q, 1 by 4 pi epsilon naught q by root over r square plus L square. It was square, okay, put a square. And again e minus q also 1 by 4 pi epsilon naught q by root over r square plus L square. Square, don't forget to put the square. Okay, so here also we will have one square. So now let us erase it. So from this portion what we will get? So square, so root over and over it one square, so root over will get cancelled, and here we have L by r square plus L square to the power half, or root over direct, you can write. So here we can represent it as 2ql 4 pi epsilon naught r square plus L square to the power 3 by 2. Now why 3 by 2? 1. This is to the power 1 and this is to the power half. So 1 plus half will give you 3 by 2. Let us erase this portion. Then let us arrange it in this manner. So 2ql can be written as P dipole moment, and what we are left. So this is the formula for electric field at an equatorial point. Now if you want to find out if now r is much greater than 2l, that is r is at a very higher distance, than 2l, so electric field will be 1 by 4 pi epsilon naught. You have to neglect l, so what will remain? R square to the power 3 by 2, so 1 by 4 pi epsilon naught P by r square plus L square, r cube. Okay, this half and this 2 and 3 by 2, from the 2 will get cancelled. What will remain? 1 by 4 pi epsilon naught P by r cube. Now in which direction it will point? It will point in this direction, of course. So the resultant electric field is in this direction. Now in which direction does the dipole moment vector point? The dipole moment vector points in this direction. The dipole moment vector points from the negative to the positive side. So in this direction. So if you want to write vectorially, so this is along which direction? This is along, you can write it as BA, along BA, because BA, that means that is from the side B towards the side A, that is from right towards the left side. So he is along this side. So vectorially you can represent E vector equals to 1 by 4 pi epsilon naught minus P vector by R cube vector. Now why minus P? That means electric field is in the opposite direction of the vector P, because electric field is in this direction. When you write minus P, no need of mentioning along BA. From this vector sign only we can understand that E is in the opposite direction of the vector P. So P is along this direction from A to the side B, and electric field in which direction? From the side B towards the side A. That is, electric field can be represented in this manner. And so you should remember this formula, very important. And another thing, let us write here EQUA as a subscript to distinguish it from the axial one. Now if a question comes that what is the ratio between E axial and E equatorial? Okay, what is the ratio? Then how you will find it? So E axial is what? 1 by 4 pi epsilon naught 2p by r cube. We are writing only the scalar form. E equatorial is 1 by 4 pi epsilon naught p by r cube. When you are writing the in scalar form, no need to mention the sign, no need to take the negative sign. So if you do, therefore, if you do E axial by E equatorial, what will happen? All the terms will get cancelled and 2 will remain if you take the ratio. So E axial equals to 2 into E equatorial. Very important, 2 marks question may come. And also one thing you can remember, see in electric field due to a point charge, E falls off as 1 by r square. That means E depends on r in this manner, and in this case due to a dipole E depends on r as r cube. So remember this difference. Here we see it is r square, and electric field due to a point charge it is r square. Okay, that's all for today. I hope this concept is clear, and do like and also subscribe. Thank you.